Hello. So I'm going to explain how to run some Python code using a system called Jupyter Notebooks, and then I'm going to demonstrate some just basic syntax, just some of the basic things you need to do uh, to, that are the sort of basis of bigger Python programs. Okay, so we're using something called a Jupyter Notebook, which is like this. It's a mixture of text and program, and it's just so it sort of gives information about what we're trying to do with the code. Uh, on here, there's a link that I've created a little webinar that explains how to download this Jupyter Notebook from a link on the DLE, and then how to actually run the Jupyter Notebook. I should say there are many ways to run Python on your system, and I I'm not forcing you to use Jupyter Notebook. This is what I'm going to demonstrate. But if you know Spider or some other system, you're welcome to use that. Okay, and there's some links in this page. There's some information. Uh, there's a link here to the Jupyter Notebook. As I say, feel free to use any system. Okay, so the basic idea is here we have some Python code, and if we want to run it, we go up to here, this command at the top called run, and what the command is print bracket quotation mark hello world quotation mark end bracket, and that's the way to print stuff out to the screen. That's always a kind of traditional way in any programming language to just make sure we can run the system. So say in the Jupyter Notebook, there are cells. This is what the code is. And then there's text. And we'll talk more about that later in the course. Okay, so printing the screen is useful to start to do more interesting things. There are things in Python called variables. So here we have a variable, and we're setting a equals 2, and then we're printing it out. So we have the same text string, a equals, now we have comma a, and this will print out a equals 2. We can use Python's little calculator. If you want to add 4 to a, we do a equals a plus 4, and then we can print it out again. Okay, so I've highlighted the cell here. We click on run, and this variable, so this is a way of just storing numbers, have a equals 2. Then we can do a little calculation and do a equals 4. So that's an example of a simple data type. So the basic building blocks of Python are variables, and variables can have different types. Just to say, sometimes they can be not just numbers, an integer such as 10, or here we have an example of 3.5y. That means it's a float. And then if we put quotation around it, it's a string. And then you can have true or false, which is what it says on the box is true or false. And here's a link that you can click on to learn a bit more about data types. And it's just a way, so Python has variables and just sometimes uh, you have to Python kind of guesses what the type is, whether it's an integer. So why? Because it sees 3.5, it thinks it's something called a float. And when it sees these double quotation marks, it sees it as a string. Okay, so these are individual variables. We can also collect variables together. Uh, and you know, you might want to do this if you were collecting people's ages or salaries. So there's something called a list, and this is an example of a list. Fee equals 23, 14, 6, 8. So it stores like four values and uses this special square brackets. You can, so here we have the print statement. We can print the whole list. So we just have the string using the print, and then comma V will print out the whole string when I run it. If you use this square bracket notation, you can get the individual element. So V bracket 0 square bracket is actually going to be 23. Uh, V square bracket 1 is going to be 14. And you can kind of assign variables as well. So you can assign V1 equals 0. Uh, let's run it. Okay, so when we write out the whole list, it prints out the whole list. When we do this square bracket notation, V square bracket 0 square bracket, this gives you the first element, 1 gives me the 14. There are also sometimes uh, functions, so if you do len and brackets V, that'll tell you how many elements there are. So we have 23, 14, 6, 8. When I put in len V, it tells me 4. And then this command here, so we start off with the list of 23, 14, 6, 8. We set the second element equals to 0, because we did V open brackets 1, close square brackets equals 0. And then we printed out, it's actually changed the list. Okay. And you'll find, so when you do data science calculations, you need to store a whole bunch of values. So if you're doing something analysis on these salaries or stock value as a function of time, you need to kind of collection of the variables. Okay. So the previous thing we had was a list. There's also kind of like variables, these things, something called a tuple. A tuple is similar to a list. Uh, so here, uh, and here, instead of using square brackets, we use uh, these rounded brackets. So here we have a collection of Jane and Roger. We write out tuple equals T. So very similar to what we did with the list. And we can also do uh, first element by using a square bracket notation. Yeah, let's take that out. Okay, and the difference between a list and a tuple is a tuple in the past we could change elements of a list. A tuple you can't change anything. So I can't update uh, uh, so if I try a line like this, and run it, it gives me a kind of error because I'm trying to change the first element because it's a tuple, just the rules say you can't change that. And this is one of the things you get with Python. You get some error message. And later on, I'll talk a little bit about how AI can help interpret these messages. Okay, so I remove that line. It runs okay. So at the low level of any computer, you have to do things. You have to have variables because you need to input values. You need to collect together variables to things like lists. And you also need to uh, do things like a loop. So here we have some code. And what we want to do is, if we want to print out, so here's the list. So we have square bracket 23, 14, 6, 8. And then what this loop does for v underscore in v, it actually, every time it goes through the loop, first time it uses 23, then it does 14, then it does 6, then it does 8. Okay, let me run it, and you see it prints out each element of the list. And so you have loops because if you want to do something to, you have a list of salaries or stock values, you want to do something to each individual element of the list, or you want to calculate something from the every element, you can use a loop to loop over the list. And loops are sort of one of the basic lower level parts of Python and many other languages as well. Okay, so another basic part of Python is a conditional value, and you need to be able to do things depending on the value. So here's a little additional link, and this just means that uh, so here the syntax says if x is greater than 0, print x is positive, else print x is negative, and you have x equals 10. Uh, and then when I run it, I have x is positive because it checks this simple expression here, x is greater than 10, so it executes this line and doesn't execute the else. And the reason you use this kind of conditional statements is because if you want to find out, you're looking at a bunch of salaries and you want to know the number of people getting more than £50,000 a year, you use something like this construct. If x is greater than 50,000, do something else, do something else. So this is a conditional statement, and it's one of the lower level parts of a programming language. And it's also, obviously part of Python. Okay, so another thing you want to do, so you want to read uh, so if you want to run a program and you want to say change things, you might want to enter input. Uh, so this is what this input does. So this input phrase prompts the Python to input something. So here I'm going to have input. It says enter your name, and then I'm going to put the value of that into the variable name. Then I'm going to print it out. Okay, so let's run it. Uh, okay, so what it's done is it's taken input, enter your name, and then Python asks me to enter your name. Then it stores result uh, in the variable name, and then we use the construct we use for print hello, comma name. Okay, and later on we'll see more sophisticated ways to make input, like using a graphical user interface. Okay. Uh, so here's all the sort of lowest level syntax of things you might want to do. There is uh, when you start taking input, so each variable uh, has, I said before, has a type, and some things are strings, some things are numbers. When this input works, so this input takes input from the user box, but it puts it into something called a string, and then to convert it from a string to a number. So in this case, I want to enter somebody's age, and you have to do this call this int function, and that'll convert uh, what's inputted into a number, and then you can kind of do a calculation with it. Okay, so if I write my age, Okay, and because I did this int, so it takes age is in a string. To do calculations with it, I have to convert it to an integer. So I have here print. So it prints out this text between the two quotation marks, comma, what's the variable age, comma, years old. And then here we have next year you'll be the string to print that out, does a calculation, adds a one to age, the variable there, and then years old. And say we'll see later is an important part of Python are functions. And what this int does, it converts a string uh, into a number. Uh, and if it's not possible, then it produces an error. Okay, so we've just seen basic syntax of Python. So I've just shown you how to assign variables, how to loop over variables, and how to use it as a calculator. So we can build all these little things together into a simple program. So just to show how everything interacts together. So we're asked to write a simple program to compute the mean of 67, 80, 39, 36. Uh, I mean, when you think about programs, it usually helps to actually try and do a test case just to check. Uh, so mean is the average. So then we want to sum up the four numbers, divide by 4. And if you put this in a calculator on an online calculator, 67 plus 80 plus 39 plus 36 divided by 4, which is the average or mean, is 55.5. And if you do this in advance, you can tell if your program is running, because if you're not getting this answer, then you're doing something wrong. Okay, so obviously doing this becomes a bit easier, but working through the test case can give you some way uh, of thinking about how to write the program. So what I've done here is my first attempt. So I want to compute the mean using Python of these four numbers. So I put the four numbers in the list just because I see here it's 67, 80, 39, and it looks like a list. I have a variable 0. I have a variable, then I have a loop. And what this loop does, it loops over every element in the list. And then I add the variable to my counter. So this thing's going to store the sum of the variables. And then I print out each element of the list. And then the idea is to calculate the average. So here I'm calculating m equals n divided by 4 because there's 4 elements. And then I print it out. Okay. Okay, so here's my run. I print out, so I'm trying to, so the idea is to calculate 67, 80 plus 39, find the mean. So I have my array. I print out this thing. I have a little counter variable to add each element of the array. And at the end, I divide by 4. Then I have my answer is 55.5. I can look at my test case because I've done it by hand. I can see I've got the same number. So quite often in in programming, what you do is you'll run a small test case. It could be you want to take the mean of a million numbers. You can't do that by hand. You might test your code by doing the mean of 4 numbers, and then that gives you confidence the code is running, and then you can apply it for the real world case of a large data set, a much larger list of numbers. Okay, so I mean, writing a program. So we're just showing all I've done is showing you some basic syntax, and then I've combined them together to do something potentially useful. But then you can always improve these programs. Uh, just by using a little more syntax. So, I mean, the problem with my first code is it works, but it's not very general. It really assumes that there's just four elements here because I have a four here, and it's not very flexible. So you can try and write the code to work for arbitrary number of elements. So I told you before, earlier up in the presentation, that len, open brackets v, comma length, will tell you how many elements there are. So when I apply len v, I get four because it counts the number of elements. And this makes the code a bit more flexible. So I could actually, if I wanted to have a much bigger list here, I could have like 100 numbers, and this len v would give me 100. But the code is basically the same. I have m equals 0, and then I've just used this slightly better syntax. M. So M is going to kind of store the sum of the numbers. I loop over the elements in the list. So we're just trying to find the mean. And then I divide by len v, which is a Python function for telling you how many elements are in the list. Okay, and this is kind of normal when you write Python code. You start off with something simple, and then you kind of improve it. Okay, so we get yet again we get 55.5. So the code's a bit nicer. And then I've also printed out what len v is. That gives us 4. Okay, and you can uh, so this has got the right answer. As you find with Python, there's a lot of libraries to do things. You may have heard of scikit-learn or some of these big libraries or pandas. And these libraries are have a lot of functionality built in. So later on, we'll study a library called NumPy later on. So a library sort of has a whole bunch of collection of useful functions that are applying. So here we're using something called NumPy. So recall, we're trying to find the mean, the average of 67, 80, 39, 36. So we'll talk about this later. Essentially, I'm calling this NumPy, which has some useful functions. Here I have my list. I converted it to uh, a NumPy object, a NumPy array. This is what this line does. And then in NumPy, there's actually just a function to compute the mean. And once I've converted the list to this other data type, I can just call v.mean. And then I don't have to write my own code to do these things. And the advantage of that is sometimes this v.mean can run more efficiently on other hardware. Okay, so we're in a slightly different world now. So uh, now we have sort of large language models such as ChatGPT and Gemini. We can use AI to write Python code. So so you have to be not slightly careful. So some of the basic examples you can just get the AI to do. I don't I don't think the AI systems are going to be sophisticated enough to actually do the coursework. Uh, and it does help to expand. So I'm just going to show you some ways of writing Python code. Okay. So I've used ChatGPT, and I've just said write some Python code to compute the mean of these four numbers, the example we did before. And then ChatGPT gives some answers, and they have a solution where say they produced a list, and then they found a function called sum, and then they're using totals that sums up 67, 80 plus 39 plus 36. And then to get the mean, you have to divide by the number of elements in the array. And I just told you this is one of the solutions we found. We get London numbers, and then we get the answer out. Okay. Okay, so there used to be some people used to be excited about something called prompt engineering. This is where when you ask the large language model, the AI, some specific question, you can get, if you ask the right kind of question, you can get different answers. And this is sort of known as prompt engineering. At some stage, like 2 years ago, this was meant to be a career, but I think most people have sort of uh, don't think it's that interesting to do prompt engineering. I thought it's a useful tool, but it's not something you can do as a kind of total career. Okay, but uh, it does allow you can by changing the prompt you can get different types of code. Okay, so in this example here, I've asked to write a so before I asked to write a code uh, to compute the mean of these four numbers. However, here I've asked to write a simple code, uh, write a simple to understand Python code to compute the mean, and uh, and then instead of using a list, it uses four variables, sums up the four variables, and divides by the number of variables and count. So by changing the prompt, instead of getting uh, something like this, which is kind of similar to what the solutions we found, we get a much simpler solution, which maybe just a bit easier to understand, doesn't involve lists, but yeah. Okay, perhaps I think one of the main advantages of using AI for coding is in the past you get mysterious error messages. So computers are really so Python, it's a machine, it's not super intelligent. So here you might type this thing, think, well, let's run it. Uh, Admittedly, and then you get this error message, syntax error expected, colon. Okay, this one's perhaps there's a reasonable error message, but you can just get some output and think, what does it mean? Uh, you can now actually type in the error messages uh, into ChatGPT, and there in this case, what was missing was a colon at the end. Uh, so in fact, I just posted in the code, and then I didn't even bother to put in the error message, and it's corrected the error message for me. It's giving me a colon. Okay. So, using these things if you get some mysterious error message, it's sometimes good to just paste it into a AI of your choice. I mean, in the past, what we used to do was uh, sort of like 10 years ago, I would just, if I get an error message, I type it into Google, and then I try and find a, a similar error message and some explanation by somebody else. Now you can post these things into the AI. Okay, so when you click on some of the resources which I made, so there is a tutorial using ChatGPT to write Python code, and also I made uh, so Google Colab is you can run Jupyter notebooks in the Google data centers. Uh, Here's a kind of link here, and the advantage of that is you don't actually run on you're not running on your laptop. It's running actually if you run Python code, it is actually running on the Google data centers. Uh, so I know some students use that for their projects. Uh, so this is an example of a Google Colab, and it actually has the AI uh, embedded in the notebook. So then what I was doing in some of the other examples, I was going to a web browser, pasting in the my request to either generate code or to understand the error message. But now if I use Google Colab, you'll actually find there's actually inside the Jupyter notebook you can actually generate code. So here I've asked to print hello world, and it's generated some Python. So I mean, there is a slight risk with using these AI tools because you won't perhaps learn as much of the basics. But on the other hand, it does speed up, so you don't have to spend so much time uh, trying to fix mysterious error messages. And as I say, it can be used as a good tool. If you don't understand some code I've posted, you can actually just ask the AI to explain it or simplify it. Okay, thank you. That's a Python example.